Now we're going to get into probability. Probability technically starts with some sort of probability experiment, and we actually call these random experiments because they're experiments that don't yield the same results each time they are performed. So in other words, regardless of how carefully they're repeated, you cannot guarantee the outcome with 100% certainty. Obviously, if you didn't always know the outcome, then there would really be no reason to perform the experiment. A few examples of random experiments would be like tossing a pair of dice and recording their sum, drawing cards from a deck, and those two are in gaming, just like a slot machine. Every time you push the button on a slot machine, you're performing an experiment. Hopefully you get better outcomes than I do when you do that. Weather conditions are recorded for a weathercast. That's in meteorology. Anytime we test some sort of part for a mechanical machinery of some type, that's a random experiment, and that's in quality control. Insurance, whether it be medical or health or flood insurance or auto insurance, whatever the case may be needed, probability is certainly involved with insurance. Testing drugs in medicine, in consumer products, testing deodorant or toothpaste for its reliability, or a new insecticide or fertilizer on crops. So all of these lead to experiments in their field. So when you perform an experiment, you have to have a sample space, and the sample space is the set of outcomes in an experiment in such a way that in each trial of the experiment only one of those outcomes can occur. We call this set the sample space, or S, for the experiment, and each element in that sample space is called a simple event or simple outcome. So an example here, suppose you toss a single die, then we could let the sample space just be the numbers 1 through 6. Now that's typically the most common sample space you would use, but you could set the sample space up in different ways, but usually that's if you are going to do some particular slant on the experiment. So you could let the sample space be either an even number or an odd number shows up, or you could even go more specific, let the sample space be a number that's the number that shows up is a number less than 3 or a number greater than or equal to 3. But in most experiments for a roll of a single die, the numbers 1 through 6 gives us more information than any other sample space we could set. Now, let's take a look at some simple event examples. So if the sample space in our die is 1 through 6, then 1 would be a simple event, 2 would be a simple event, 3 would be a simple event, and so on. Now, if we toss 2 coins and wanted to observe their outcomes, we could let the sample space be all ordered pairs of the 2 coins. So in other words, one simple event could be that we get head on the first coin, head on the second coin. Another simple event could be we get head on the first coin, tail on the second coin. And then another simple event would be we get tail on the first coin, head on the second. And then the last simple event would be that we got tail on both coins. So each of these 4 would each be considered a simple event. Now, if you selected 5 heart cards from a deck, there's really too many 5-card hands for me to list. But a simple event in that case could be just one specific 5-card hands, like the Jack of Hearts, 5 of Clubs, 3 of Clubs, 7 of Diamonds, Ace of Spades. That's one of the simple events. Now this experiment would actually have over 2.5 million possible simple events, so obviously we're not going to list all of those. The next thing I want to talk about is event spaces. An event space is actually any subset of the sample space, and so it could be any subset. So when you're asked to find a certain event, your event should represent some subset of the sample space. Now, the event space can be the entire set, the entire sample space, or the empty set, or really anything in between. Now, if our event space contains only one event from the sample space, then that event space is a simple event, but if it contains more than one event from the sample space, we call it a compound event. Let me give you an example. Let's go back to tossing our die. We can let the sample space 1 through 6 represent our die. Let E be all even numbered rows. Okay, so there's an event space for all even numbered rows. Well, since even numbered rows actually includes 3 values from the sample space, 2, 4, or 6, then that event space would be a compound event. But if I said all rows, if I let E represent all rows greater than 5, well, that only contains a single simple event, so therefore the number 6. So therefore we would say that that event is a simple event. What if I said let E be all rows divisible by 3? Well, there's 2 rows that are divisible by 3, 3 and 6. So in that case, we would have another compound event. Or what about all rows divisible by 5? Well, there's only one row that's divisible by 5, and that would be if you roll a 5. So that would be a simple event. What about all rows less than 0? Well, if you look at your sample space, you'll see that there's nothing in here that indicates you can roll a number less than 0. So that event would be the empty space, or the empty set. And then all rows less than 10, that represents everything in the sample space. So in that case, your event space is actually the same as the sample space. So anyway, so as I said, you can see your event space can be the empty set or the entire sample space, or it can be anything any subset in between. Another example, let's suppose we select a single card from a 52 card deck, and the sample space is going to consist of the set of all 52 cards. Now let's let E be the event of selecting the king of clubs. Well, then this would be a simple event because it would only contain one card from the deck, the king of clubs. Let E be the event of selecting a king. This would be a compound event because there's multiple elements that would fall in that set. In other words, all 4 kings. And then it says, let E be the event of selecting a green card. Well, if you're familiar with a standard deck, you'd realize this is the empty set because there are no green cards. The cards in a standard deck of cards are black or red. So this would be the empty set. And then let E be the event of selecting a card that's red or black. Well, that would be the entire sample space because all cards are either red or black. I want to finish this video with just talking about 2 major types of probability. There's theoretical probability and there's empirical probability. Now, theoretical probability uses basic assumptions and reasoning to determine probability, where empirical probability is determined through experiments or research. So, for instance, let me just pose this. If you tossed a coin, if I asked you what the probability of heads were on a coin toss, most of you would say 1/2, or 1 out of 2. Now, you didn't have to do any experiments or do any research to get that number. So therefore, this would be a theoretical probability. But let's say I asked you to toss a thumbtack, and I asked you the probability of the thumbtack landing point down. Well, if you assigned a number to it, let's say 0.77, then maybe you tossed the coin 100 times and it landed down 77 times. So then you assign the probability 77 out of 100, or 0.77. But see, the difference between this example and this example is on this one you had to perform experimentation to calculate the probability. A pair of dice are tossed. The probability of rolling a sum of 7 is 1 out of 6. Well, we can figure that because there's 6 ways to roll a sum of 7 out of 36, and 6 out of 36 is 1/6. But what if a domino is tossed, and you wanted to know the probability that it lands on a particular side, like the flat side, the edge side, or the end side? Well, maybe you toss the domino 1,000 times and find out it landed on a particular side 50 of those 1,000, so you assign the probability 50 out of 1,000, or 0.05. Well, in that case, you performed experiments, but over here we didn't perform an experiment. Over here, it's not like we tossed the die 1,000 times and then counted how many times it landed sum of 7. See, because this was theoretical, yet this is empirical. And so you can read the other two examples. You can easily calculate the probability of getting a particular poker hand from a deck of cards. And again, you don't need to perform experiments. You can use mathematics to do that. But if an insurance company is trying to find the probability that someone files a claim during their first year of insurance, then this is because that they've researched this and performed experiments over all of the people that have purchased insurance in the past, and they're able to assign a probability. So that would be empirical. So again, the roulette wheel, you can find the probability that a roulette wheel stops on a particular number using mathematics, but the probability that it will rain today is basically calculated based on the past days that are similar today. And so you can calculate the rain based on experimentation or data that you've kept. And so that's all I want to talk about in this section. We'll continue discussing aspects of probability in the next video.